In my first video in the series titled Basic Electronics Part 1, What is Electricity?, I touched on direct current, where I used marbles in a tube to represent electrons moving through a wire. Simply put, current or DC, direct current or DC, flows in one direction. So let's take a look at alternating current in this video, which flows in two directions, alternating between the two directions as seen here. This is how we generate AC. If you take a metallic mass, like a rod or a cylinder or a wire loop, and rotate it in a magnetic field, the flux lines in the magnetic field cause electrons to flow, resulting in electricity. Magnets have two poles, north and south. When a certain part of the metal mass cuts through the north pole of the magnet's flux lines, current flows in one direction, which we'll call positive. When that certain point cuts through the south pole of magnetic flux lines of the magnet, it causes the current to flow in the opposite direction, producing a negative current flow. As it keeps spinning, the current flow changes direction in unison with the rotating metal mass. Thus, you have alternating current, or AC. Here I have taken apart a fan, and we're going to look inside here because it's an electric motor, and electric motors can be used as generators. Here you have a metal mass right here, and it's not magnetic. In here you have a cylinder that's not magnetic. Then you have the wire windings, which make up part of the magnet. But just as it is, this is not a magnet. But we'll show you how it becomes an electric magnet. First, I'm going to put up a backdrop so you can see a piece of metal that I'm going to dangle in front of it to show that there's no magnetism here right now. Okay, with this paper clip on a string, I hold it in here, and nothing other than my own motion is influencing that paper clip. It's not going inside or anything. But when I turn the fan on, it will. There it is. It goes inside. I shut it off. I turn it on briefly, and there it goes in again. If I leave the fan on, it'll stay in there, and that'll happen there. That is where it sticks inside the magnet. Now, if you spin that cylinder that I showed you early inside of that magnetic field, you'll get a trace something like this. It's a circle. The positive voltage is on top. When it changes direction, the bottom voltage is on the bottom. If you flip it over, flip the bottom away from the top, you'll have the time domain. This adds a graph so it shows it as it moves along in time from top to bottom. It also generates a sine wave. Okay, we've reassembled the fan, and on it we have hooked up my oscilloscope to the electric cord with the two clips you see there on the prongs of the electrical cord. And we'll use an air compressor, an air hose, to generate electricity by blowing the air in the fan and spinning it. The faster it spins, the higher the frequency of the sine wave becomes. You see it scrunch together as it's sped up. And if we hold it there, it'll stay. The top peaks are how much voltage it's generating, and we can see it right now. It's around 500, and the faster it goes, the higher the frequency gets. You can see the lines crunching together to get even a higher frequency. Right now it's 31 hertz, which is 31 revolutions per minute, and we're up to 600 and right around 651 millivolts. If you look at the peak to peak, it was at 1.29 volts. So when we let it wind down, frequency gets slower, the voltage drops, and we now have 0 volts. So here we took our fan and we put a marker on it. We're going to call this 0 degrees. This is when we start the fan rotating. As we rotate it up to 90 degrees, you will get a 90-degree part of that sine wave, which looks like this. Then when we rotate it again, another 90 degrees, that'll be 180 degrees from where we started, and it will look like this. When we rotate it again to 270 degrees, or negative 90 degrees, you'll get 3/4 of the cycle, and you'll be down on the negative peak voltage. When you rotate it again, it will come back to 360 degrees, or 0 degrees for the next cycle. So that is one full cycle of that fan spinning, and you get that sine wave. You keep spinning it, and you get the chain and chain along of one cycle after the other, as seen here. Now there's one thing you should know about AC. It can be rectified by a diode. And by rectifying it, you cut off half of the cycle. So if you do that, you will have pulsating DC. So you can convert AC to DC just by adding one diode and then filtering it. If you add two diodes, you can put the bottom of the cycle up on the top of the line, and you'll have full wave DC. The other one was called half wave DC, or half wave rectification. It's all flowing in one direction, but in pulses. So I hope you found this useful and enjoyable. If you did like it, please like and please subscribe. Thank you for listening.